Hey everybody, welcome back to another episode of the Offset Podcast. And today we're talking about that hip, cool phrase, vibe coding, and how it pertains to post-production workflows. Stay tuned.
Support for this episode comes from Flanders Scientific and the XMP 270 and XMP 310, the accessible, lightweight, and versatile monitors helping to bring HDR monitoring on set while also being very well suited to post-production work. Learn more at flandersscientific.com.
Hey everybody, welcome back into another episode of the Offset Podcast. I am one of your hosts, Robbie Carmen, and with me as always is Joey Dana. Hey Joey, how are you, man?
Hey everyone.
So Joey, I just have to apologize up front. I'm probably going to use the word coding a lot here when you drives you absolutely insane, and we should be using programming. So I apologize to you and our audience. I'm just going with the phrase du jour, and that is vibe coding.
Yeah. I hate the term coding because it's not a real word. You're not coding anything. You're not encoding a message. You're not encoding. It's wrong. It's called programming, and I don't even know what a vibe is, so I don't know what a vibe coding is supposed to be. So half of this is going to be me screaming at the clouds saying I don't like these newfangled words. Newfangled words or not, there are still powerful workflow technologies available to us now that are new and we should talk about.
Yeah, totally. And our dear viewers will understand your get off my lawn attitude. I mean, after all, this is our 51st episode. So if they haven't gotten used to, Joey getting on a soapbox about something, especially highly technical computer-based concepts, then, you should go back and watch some previous shows.
Because you're still on my lawn at this point. Well,
yeah, there's some good rants to be had. But anyway, before we dive in, the same usual housekeeping as always. You can find us on social media just by heading over to Instagram or Facebook, searching for the Offset Podcast. You can find our complete library of episodes, including show notes and in some cases some additional downloads and such, over at the offsetpodcast.com, where we have our whole library. And you can also find us, of course, on any major streaming platform like Spotify, Apple Podcasts, and the video version of the show is obviously available on YouTube as well, where we have a lot of you chiming in there. Please drop us a comment, like, subscribe wherever you find the show. Tell your colleagues and friends. Every bit goes a long way. So, Joey, let's start. I sort of want to talk about a little bit of the Wayback Machine and a personal sort of anecdote about this. And we're not going to have to go that far back in the Wayback Machine. A couple of years ago, probably 5, 6, 7 years ago, I started realizing, because I was seeing, at the time I was doing a lot of international travel, a lot of speaking at events, conferences and things of that nature. And I kept encountering this type of person that was involved in post-production somehow. Right? They were an editor, they maybe an engineer here and there, they were a colorist, they were a DP, and you'd be talking to them and they'd randomly just drop, oh, this app that I made, oh, this tool that I made, right? And yeah, sure, like the really sort of involved people in our industry have always done this level of tinkering, right? Something's not available, I'm going to make it myself. And it used to be they did that with, metal and plastic bits and a whole bunch of solder and, like physically putting something together. And what I realized about 5 or 6, 7 years ago is that shifted largely to application development. It's shifted largely to programming. And so, that's when I first started hearing it. But at the time, this was people who had invested a lot of time in learning Python, JavaScript, C or C+, or like any other range of languages and tool sets out there. And I tried to get into that stuff, man. And, my brain just, it's a limitation. Let's put it that way. Like I get the idea of order and syntax and whatever and calls and responses, and I get it on some level, but I just wasn't made. There's some people, and I'm sure you've encountered these people, who can look at programming language, or I'm going to use the word code here, or look at a whole thing laid out in front of them and go, oh yeah, I totally know what's going on. It's like they're reading, it always reminds me of like the first Matrix, right? When all the numbers are streaming down the screen and somebody's like, oh, see that guy running right there? And you're like, what? Am I crazy to think that that's like kind of old school programming takes a little bit of a different level, different mindset to kind of get your head around?
Yeah, and it's an important concept that I think a lot of people don't really know how to label, but because I've got a pretty decent programming background. I'm not the greatest programmer in the world, but I've always made my own tools, made my own kind of workflow enhancers, stuff like that. Never made them to the level where they were good enough to really share among the world and support, because support is a whole nother thing that you need to get into if you start selling software. But I have, since early days, you know, people have always, there's always the fun story that I bring up is that I invented Dropbox 3 years before Dropbox Incorporated existed, which is true. You can go to the Wayback Machine, internetarchive.org, and I can prove that to you. But, you know, even 20 years ago, I was writing like some web-based applications to optimize the workflows for the post house I was working with at the time. And what you're really talking about is a concept called abstraction. And it's something that's used in programming, but it's also something that I like to think about in kind of all things. And what abstraction is you take specific things and you generalize them. With programming, that happens with programming languages, that happens with device drivers, that happens with what's called abstraction layers, where, okay, for example, every single software that uses a Blackmagic hardware interface doesn't talk directly to the Blackmagic hardware. They talk in a standard language. They basically say, hey, I know how to send video to a device, and then Blackmagic writes the software that actually handles, well, okay, this is a Decklink 8K, this is a Decklink 4K, this is a mini monitor. That's why After Effects, DaVinci Resolve, Premiere, Media Composer, none of them need to know the specifics of your Blackmagic output hardware. They just know we're using the Blackmagic API that then abstracts all the technical nonsense that you don't want to have to do, and then handles it. So
before we move on, Joey, can you just real quick, because I think people have heard these terms before, API, SDK, like what do those terms mean? Because that's the sort of abstraction layer you're talking about, and sort of the nice package that companies put their abstraction layer in. What are those terms? Because you hear those terms all the time. Go get the API key, or go get, or download the SDK. Like, what does that mean?
Yeah, that's actually a really, really good point, because, people might not know what these acronyms do. SDKs and APIs, specifically, SDK is a software development kit, and an API is an application programming interface. People will sometimes interchange these things, but they're actually pretty different. An SDK is a set of libraries and base level source code and examples and ways of doing things that lets you use someone else's software. For example, Red provides an SDK that they give to Adobe, they give to Blackmagic, they give to Avid. Avid, Adobe, whatever, will write calls to the libraries in their software that says, hey, decode this R3D file and then give me back the image. Okay, so you're using Red's software intellectual property, but you're actually inserting it into your software. For the kind of tools we're going to be talking about, we're probably not going to be doing stuff like that. What we're really going to focus on in a lot of cases is in API, where you're using software to give commands to something else and get data back, right? We're not actually, for example, if we were talking to Frame.io to manage some assets, or we were talking to DaVinci Resolve also to manage some assets, right? We are not writing DaVinci Resolve into our program. We're not writing Frame.io into our program. We are just communicating with those outside entities. That's what the API does.
And I think that's a really important, really early distinction to make as you go down this path, is that you inevitably, and as we'll explain later, you'll get the potential for frustration exists, because you're like, I want to do something, but it's not working, or I can't do it. And that's not always bad logic. That's not always bad thinking. That's not always bad programming. That can be as simple as this tool that you're trying to integrate with and get something to do doesn't expose these bits, these API calls, or hooks to be able to hook into to do that very thing. And in fact, if you think about it, it sort of makes sense, right? If you're a big company and you've spent millions or billions of dollars developing software, you're not all of a sudden just going to go, hey, sure, Joe Schmo, do whatever you want on top of to modify our software, etc. That's why there are certain things that, like, in our world and Resolve, people will be like, oh, I'd love it if Blackmagic would just expose that. And what they're trying to say by that is, I wish that programmers at Blackmagic would build in these API hooks so we can direct Resolve or whatever the tool is to do something. And sometimes that is for strategic money reasons. Sometimes that's just because nobody's ever thought that somebody would need that use or do something like that. So that's an important distinction right now, I think, to make, is that just because, as we're going to discuss, coding has gotten and programming has gotten, in some ways not, much easier, you are still at the behest of the ecosystem around you that you're trying to control with these programs, because not everything's going to expose these hooks to do exactly what you want.
Yeah, because specifically what we're talking about with writing our own tools for post-production workflow, obviously we're going to be connecting to a lot of different existing tools and existing workflows. That's the whole point, right? We're not talking about, I'm going to write my own color corrector here, I'm going to write my own nonlinear editor. If you want to do that, go with God, enjoy. But for practical purposes of what we're talking about today, making our post-production workflows faster, easier, more flexible with custom software, we're really talking about using APIs to do clever things across multiple existing software and workflows.
Yeah, totally. So the thing I want to get into is this distinction between, and I'm going to use this term just because it's something that I've heard, but not necessarily the right way to posit it. But it'll kind of, I give the old versus new, or the hybrid approaches some legs here, and that's sort of what is vibe coding and what's the opposite of vibe coding. I have been in the habit recently of calling the non-vibe coding stuff analog coding.
God, I know hate that too.
I know you hate that. It's cheesy. Somebody I know and is well respected in the industry gave me that term, and I was like, oh, it kind of makes sense. All I'm going to say about analog coding, whether you hate it or not hate it, it's just traditional programmers, right? People writing the actual code themselves, bug checking it, running debug algorithms, looking at it, syntax, etc., versus sort of the newfangled way of vibe coding. And vibe coding is a relatively new thing. The Google machine tells me that this word was sort of coined by this guy, Andrej Karpathy, in February of 2025, actually. And he posted about it on Twitter, and his definition is a style of programming where you essentially give yourself over to the AI, describing what you want in natural language and just go with the flow. You're not carefully reading or understanding all the code that the AI generates. You're just kind of vibing with it and iterating based on what works and what doesn't work, right? You can see the steam coming out of Joey's head right now. Okay, so let me give you a practical example of something like the vibe coding. So let's just say that you wanted to, I don't know, do something really simple, like super simple. Like when you log into your Mac, you want a couple network drives to automatically mount, right? A lot of people do that through, the built-in OS, but you could write like an Apple script. That's how I do it, right? I have a little Apple script. So through some trial and error, I wrote an Apple script, trying, I didn't know Apple script very well, some syntax or whatever. And it took me 5, 6, 7, 8 iterations to do it. But then I realized, but now I want it to give me a notification when it mounts these drives. And I got down this hole where I was sort of starting to go like, okay, I'm learning, I'm building, and making mistakes. And next thing you know, I spent like a stupid amount of time, like 4 hours trying to get, notifications on 2 drives to pop up to mount. And I'm like, this is stupid. I go on Claude or ChatGPT and I say, hey, here's what I'm trying to do. Can you do it for me? Thanks. Bam. Here's your Apple script, put it in your startup items, done, right? Yeah. So I literally, in just natural language words, described to the system, the AI in this case, I think it was Claude at the time, and explained what to do, and it spit out something that I had previously spent a few hours trying to figure out. That's kind of vibe coding, right? And that's like an ultimate simple layer. This can extrapolate like leaps and bounds, extrapolate exponentially how complicated it is. But that's basically the gist, using natural language to tell the machine, the AI, or the platform that you're using, we'll get into those in just a little bit, hey, this is what I'm trying to accomplish. Can you help me do it and spit out something?
Yeah, and I've kind of always said since these AI and LLMs kind of first started becoming usable, that I consider them to be kind of the highest of high-level programming languages. When you talk about the level of a programming language, you're talking about the distance to the hardware, right? Again, how much abstraction are we doing between you, the operator, and the actual...
This is that next level up, right? This is like you're taking something that's already abstracted through SDKs and APIs.
And it's layers upon layers upon layers. You know, early days, the first computers were defined, you know, how do you go from, for example, a calculator to a computer? A calculator has a set of specific ins and outs, essentially, right? A computer follows instructions. So the first computers were programmed with very, very simple, low-level instructions that directly manipulated things like memory and CPU instructions and stuff like that. Then we wrote assembly language to kind of abstract that a little bit easier. So you would say, okay, instead of pulling up the actual instruction value for what move memory is, now it's MOV. We can move this memory, but you're still really low level. You're talking about what bits and bytes of memory to put in different places, and then
but you can see how that
CPU.
You can see how that extrapolates up, right? That like,
but then we go and we write languages like C and C++ that have almost English-looking syntax, for, while, if, things like that. And that, again, gets compiled down to machine code and then binary and all that stuff later on. But for the programmer, it's easier. Then we came up with scripting languages, Python, JavaScript, etc., where you don't have to think about what the computer's doing. The back end of the programming language is handling things like memory management and stuff like that. Great, easy. Now we get to these LLMs where you don't actually need to write the instructions in a specific language. You can write the logic out in English and ask it what to do, and it will extrapolate. And this is where it's important to kind of think about what these LLMs are good at and what they're not. What they're really good at is looking at gigantic data sets, because that's what they were trained on. Like you said, you were trying to write a specific easy little Apple script to get notifications to work. Are you going to sit through reading all the documentation of how AppleScript handles notifications? Or was Claude already trained on all of that documentation and examples and such, and can just easily say, okay, he's asking for a notification in this format. This is what a notification code looks like in AppleScript. Boop, 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 boop. Put those two things together and if it's the exact instructions you want.
And if it's well trained, it also can. So the interesting thing about this is that, to say it in a slightly different way, these tool sets are only going to be as good as the training that they receive, right? And a little later on, we'll talk about some, because everybody knows about the Chat GPTs and the Claudes of the world, or whatever, and those are perfectly fine for doing base level thing. But there are platforms that excel at much more sophisticated full stack programming. And the reason that they're more sophisticated and more functional than, say, a ChatGPT or a Claude or whatever is because they've been trained on this specific type of thing with a lot more nuance and a lot more information than, say, a generalized, public kind of thing, system like Claude or ChatGPT does. That's not saying that those major LLMs can't do a relatively good job, but if you were, like AppleScript, whatever, ChatGPT, fine, Claude, fine. If I was getting into something where, like, oh man, I have this specific FPGA board that I'm trying to I bought on AliExpress or whatever, and I'm trying to program, and it's all hex code, like, yeah, that's probably not going to work too well with these big LLMs.
This is an important thing to kind of remember too when you're dealing with LLMs, is they only exist in the world of already solved problems, right?
Correct.
They're not going to come up with new algorithms. So, okay, you want to have have Claude write you a program to search through all of your scripts and, extrapolate certain things for your producer or something. Great post-production workflow use case. Okay, fine. But if you want, and it's going to be great at that because all of the kind of key intellectual parts of what you're asking it to do exist out in the world already. You are not going to ask Claude or ChatGPT or anything else how to make Cold Fusion work, or how to get or in a more reasonable example, how to optimize a sorting algorithm for performance on a new CPU that they don't know about. You know what I mean?
So can I tell you something?
Optimize, it can do, has already been done. If you are trying to come up with, color science, for example, if you're trying to come up with some kind of new and novel color matching function that nobody's done before, no, these LLMs are going to have no idea what you're talking about because there's no training data surrounding it.
Support for this episode comes from Conform Tools. Conform Tools allows you to translate timelines between Premiere and Resolve and other NLEs while automatically solving common issues that normally need to be fixed by hand. Avoid time-consuming trim and transfer issues and securely send large media files to collaborators at a fraction of the size and in minutes instead of hours. With a growing toolbox of features, let Conform Tools handle the tedious stuff so you can focus on the creative. Built by post-professionals, Conform Tools helps editors, colorists, and conform artists move faster and finish stronger. Learn more at conform.tools. So one of the things that I think is an interesting development as these two, so obviously people over decades have built up their skill sets in programming, and there's, a huge repository of talent, of code, APIs, SDKs, whatever. Along come these LLMs, and we get into this vibe coding world where it's just speak your mind, create a tool. I've always been interested where that combination exists, right? Because it like anything else like this, that there's no such thing as automagical perfection, right? Like it doesn't, like, you're not going to just do something. And so, like, even in my own journey over the past year or so, I've been led down a lot of holes where it's just been like, oh, okay, we just spent 3 hours going through this and you forgot about this, or you hallucinated this, or that's not a thing, like, or whatever. There's a myriad of problems with there. So it got me from the very beginning thinking about, well, what do real programmers do in this? I mean, do they just revert back to the old ways and doing everything by hand? How do they leverage? So I started looking into this, and I started talking to quite a few people, and one conversation popped out. We have a colleague that works at one of the biggest post-production and production installations in the world. And I was asking her about, she at her role there, she was hiring people to do sophisticated, programming work. And she said almost all the programmers that she's interviewed over the past, half or so decade, they use both. They are doing repetitive, difficult, tedious tasks with LLMs or some other sort of AI, but they are still doing the ideation, the bug, the process, the thinking, the big picture, the 50, like, I want it to do this kind of thing. They're still doing a lot of that work by hand and utilizing the LLMs as just another tool set, almost like another library in their world. Or for us, it would be like another plugin or something like that to try to push the ball faster. Because to them, it's not about, they're going to arrive at the same point, probably, right? Maybe, likely. It's just whether it's going to take them 3 months to do that, or it's going to take them 3 weeks to do that, right? And that's where I think that a lot of, people who already are good at programming are looking at these tools in vibe coding. It's like, okay, look, I can get 90% of the way there with this tool doing what I want, like doing it automagically, and then knowing with my knowledge, I can go in that's BS. Nope, this is inefficient. They're double checking that work, and that really makes a lot of sense to me, right? Is that both people like me who are newbies at it just go, wow, this is amazing, I can create this thing. But even in my short time, I've gotten more into it and be like, hold on a second, like that. Why are you doing it that way? That doesn't make sense. Like, think about it this way, and the more knowledgeable about it, it's actually like this weird, I don't even know what it would be, like inverse square law or something, right? Where like the more you get into vibe coding, in a weird way, the more you get into traditional programming, because 100%. You're wanting to like double check it, figure it out, understand it better, rather than just accepting it as like the only way of doing it, if that makes sense.
Yeah, and this is kind of the most important concept I think that anybody can get when it relates to using LLMs for programming or anything else, actually, which is the universal truth of garbage in, garbage out. You know, we deal with it in color grading. You give me DV cam footage from 1999 that's overexposed. I can only do so much.
So much.
You give the LLM something stupid like write me the next cool app that's going to make me rich. It's not going to give you anything actionable. So the most important thing of any of this is to be able to conceptualize and describe the totality of the problem you're trying to solve. And when I say totality, I mean, how does it handle all different kinds of inputs? How does it do X? What does it do with Y? What do you want it to, how do you want it to be structured? And to ask the right questions and to give the right terminology and the right structure, you need to understand how computing works. Otherwise, you're going to, like you said, go down these rabbit holes of hallucinations that don't get you anywhere. So if you can clearly define the problem, and I mean verbosely to the point of not just, okay, write me something that will take my EDLs and clean them up for how my client wants them. No. You need to be able to say, okay, the EDL consists of a tab separated list with source timecode, record timecode here. For our application, we might not care about source timecode, but you still need to have it in the file. You might need to explain stuff like that. You know, you need to dig down to the base level concepts of what you're asking the computer to do. And then, the LLM can do a really good job of cross-referencing its gigabytes of training data and putting all those pieces together.
100%. And it's actually really funny to me that part of this this movement, if you will, is no different than the analog, regular programming. Like there's some big picture concepts that are unique. So as you said, clearly defining the problem in a way that's more than just, as you said, make me some cool things, like really explaining it step by step.
And not just defining the problem for the LLM. You should be able to sit down and draw out a block diagram of exactly what you want this software tool to do by yourself first. That way, when you start, because you're not going to try to one-shot the whole thing and say, okay, give me this tool that does X, Y, Z, and all these different things, right? You're going to probably want to break it down, be like, okay, here's the overall concept. Now, write me a module that does this EDL processing. Write me another module that handles file I/O to send things to Frame I/O or Dropbox or whatever like that. It's easier to break the problem down into smaller chunks, and that you can then define those smaller chunks in their totality. But in your head, as kind of the virtual product manager, you need to understand what every component of this imaginary tool is going to do and describe how they all connect, not necessarily all in one easy description.
Totally. And I would add on to that, it's also like I know this is going to sound funny, but there's a level of like hubris breakdown that has to happen here to get the most out of these tools, right? Like if you're just like, oh, well, of course I know this, or of course, like, I think it's also important as you're working through these problems, sort of to define and be honest with the platform, the LLM, what you do know and what you don't know, right? So like if you know, like, hey, I know that this tool uses, I'm just picking one out of the hat, multi-part chunks to do an upload, right? Like I know that, but I don't know how encryption works for multi-part uploads. Can you tell me how, like, can you build that in? Like just kind of, being aware of the things that you don't know and the things that you do know, I think also really give that, the process a lot more validity. And the other thing I would add there too is that like, I can't discount the idea that the more knowledge that you have about a subject, the better off you're going to be as a, air quotes, vibe coder, right? So if you understand how, like in the example I just gave, how HTML works, how CSS works, how basic JavaScripting works, whatever, like you're going to be a leg up to know when that LLM is doing something stupid, it's hallucinating, like it just can't possibly work like that. Like I'll give you a great example of this. A couple weeks ago, I was sick. I had I was in bed for a week or whatever, and I was just playing. I was like, oh, you know what? I'm going to build a new dashboard and Home Assistant for my Ubiquiti, my Unify network, right? And like instantaneously, it gave me this like beautiful dashboard, and I'm like, oh my god! And then I'm like, hey, this doesn't appear to be changing. Oh, that's just a placeholder because it looks cool. Really? Like you can tell me that information from this device? Nope. No access to that device. I'm just like, it just looks cool. Right. And like very easy. I'm like, very quickly, I'm like, oh, so you don't have access to this sensor on this switch. Like just knowing some of that terminology, it's like, oh, you're correct. I don't have, but I do have access to this sensor, which we could extract. You know, like I'm just saying, some of that baseline knowledge about whatever you're trying to do, like even if it's just conversant knowledge, even can really go a long way in helping build a better tool.
Yeah, even the best LLMs in the world, even a Star Trek level computer human interface that is like way beyond anything that we can even conceptualize, right? If that existed, it would still only be as good as your ability to describe a problem and describe a concept, right? And that's totally the most, like, basically take your LLM and say, if I could just hire a programmer who is very good at this one particular niche thing to do this module, what would I be telling them, right? It's the exact same skill set of managing people, except you're managing robots.
Right. And the last thing you said there is really important too. I think the other part about this is evaluating output. I think is a really interesting part of this, because like you'll get something out of this, but then what? Like your job as the human is to look at it. So like, and I've found in my experience too that like, okay, fine, it outputs something for me. I deploy that, I look at it, and I'm like, that leads to more iteration, more testing, more whatever. And here's the danger of it, right? Is that like all of these models and platforms, they have relative, I mean, not for most people, they have limits in the how much you can press them, how much heavy lifting they're going to do in any given time period, right? So like you will save yourself money and be more efficient too if you can do this in this kind of work in an organized fashion, right? So instead of like you get an output from an LLM for something, you deploy it, and instead of going fix this, give me a new file, fix this, give me a new file, just like you would like a product manager would in the real world at a regular software company, they would build a report that says, here are all the problems. I'm ranking these problems in the orders that they need to be fixed based on severity. This is what I would like to see the outcome be, and feed that back. You'll actually end up being a lot more efficient with the costs and the use of your LLM than just trying to one-off and iterate things as they come up.
Yeah, and that's where I think a lot of people fall down, is they don't know how to essentially beta test, right? This is a specific skill to computing that I think a lot of people need to kind of get better at, which is how do you test something that you're not 100% sure of? What that means is, and this is something that an LLM can't help you with. This is something that Google can't help you with. This is something, you need to know, again, assuming you already know the totality of the problem you're trying to solve. So you have it mapped out in your head or on paper what this tool does. Now, how do we test it? Well, first we feed it ideal things. We feed it the most easy possible input, the most easy possible scenario, and make sure that works. If that doesn't work, well, we got to start figuring out the base level stuff, right? But then what you got to do is you got to start testing things, what we call boundary conditions, where, okay, everything makes sense, except I'm going to do one thing that might be unexpected. I'm going to put a negative value here where it's only expecting a positive value. I'm going to put a special character in this string for the name of the timeline that this tool is going to manipulate. I'm going to see how it handles drop frame versus non-drop frame timecode. I'm going to change the frame rate of this one source. And the way you do this testing needs to be both organized and methodical.
Well, I got you.
Methodical is the word. Because just like any other kind of troubleshooting, you want to reduce the number of variables. So you built this awesome tool that you vibe coded to handle some kind of post-production task. Let's say it does some kind of manipulation to a timeline. Okay, great. Works on your first couple timelines you tested on. Cool. Now what's the next step? We need to go through and remove variables. We need to go through and test it with every frame rate, okay? And test it with every frame rate but nothing else changing, which means you need to go into your NLE and make 5 identical timelines of different frame rates, right? Test all of those, see what happens. And then that will introduce problems that you need to solve. Okay, great. Now we've got the frame rates solved. Then we figure out things like drop frame, non-drop frame, different timecode formats. Do the same thing. Then you do, great. Okay, I'm going to try it with different resolutions. Then I'm going to try it with different sources. Then I'm going to try it with different naming. But the big thing here is we're looking at the structure of what we want the tool to do, and we're finding out what we can test that only changes one variable. We're not going to say, okay, I've got 5 different timelines from 5 different clients. I want to run through this tool. Just throw them willy-nilly at there. You're going to end up with 15 different errors that aren't able to be tracked down.
Yeah, you don't know what you're testing at that point.
Exactly. So you need to be able to build test cases to input into this tool you're making and understand how to do that where you're only changing or testing one variable. You want to be able to verify, okay, this timeline going through this tool works 100%, right? That's kind of our base level. Then we change one variable. That works 100% great. Then we change that same variable again to another thing. Oh, that broke. Yeah. Now we figure out what we need to fix in that pathway, and we figure out how to fix that before we start testing other things and throwing other random stuff at this. So being methodical about your testing is something that the LLM can't really help you with. It comes down to you understanding the problem, and nobody else can do that for you. That's how you kind of get from the, wow, I just told the LLM to write this, and it came out with all this output that actually kind of works. Awesome, this is really cool, to this is a tool I can actually use in my day-to-day work and trust. That's how you bridge that.
And I actually think there's a couple middle milestone points on that process too. So I'll talk about this in just a moment. One of the examples I want to give is something that I recently built using this methodology. But one of the things I was thinking about, and again, I think it's because I know the right questions to ask. So I built a tool, this client portal that we'll talk about in just a minute, and yeah, eventually I needed to test it, right, with various, and you've been testing it in various uploads, and we've found some problems. But my point is, even before I was ready to go out and test various uploads and deliverables, I was asking it audit level questions like, oh, I noticed that you created this link that seems to be a public link. Is this a security problem that I'm going to be facing, right? Or I noticed that took, it seemed like it took a long time to produce that page. Is this the most efficient way to do it? And those are just really super high level questions, right? But security, performance, redundancy, fallback. If this doesn't work, what happens if this doesn't work? Is somebody presented with a warning? Is it a hard crash? All of those iterations as you're developing, you need to start thinking a little bit more like a developer. Okay, if this goes bad, what happens? If this doesn't work, what happens? And, or how can we get this better? And I think that one of the problems right now, and it's not just unique to vibe coding, it's just our society in general, right? Is that something, a computer does something cool and we think it's a messiah, and it's just no.
It's not done.
You can get very deer in a headlight by some of this output, and you're like, oh my God, this is the coolest thing. And then you start banging on it and you realize that the LLM just made some placeholders for you, like I earlier described. Or, oh, really? That secure upload portal? Everything's totally not encrypted and available in the public. You probably don't want to fix that, things of that nature.
And again, that goes back to, you need to have a base level knowledge, and you need to, if you're trying to get into making a tool that does something, yes, we don't have to go down on the individual line by line code level anymore. That's a great time saver. But if you don't understand the overarching concept of what you're trying to do, that's where you need to focus your self-education, if you will.
So let's give a couple examples about this. I know you have a couple yourself that you've used these tools a little bit. I'll start out with the one that I've been teasing. So about 3 weeks ago, I got a renewal bill from a vendor that we use for our client upload portal, and go, oh, they're raising their prices again, right? And it was one of those things that I was using. This particular part of the portal I was using specifically with a couple clients. I think you'd only used it once or twice. It was just it really was turning out not to be worth the investment. And with this stuff in mind, I turned, on a lazy Friday afternoon, when I turned to Claude and said, here's what I want to do. Here's the model of what I'm trying to do. Help me do it. And that was a pretty relatively straightforward set of instructions that I gave it. So number one, I knew that I wanted to use storage that was not local storage, like not a server running in my basement or whatever. I wanted to use something that was globally available at even at edge cases, right? And so that kind of meant something like S3, Wasabi, Cloudflare R2 or whatever. So like before I even plugged, went to, Claude.ai, I started looking at, okay, what are the costs involved with these services, right? Oh, this one has egress. This one doesn't have egress fees. Oh, cool. This one over here, it doesn't charge me a fee whether for whatever this operation is. I like that. And I started building this pros and cons list of the different storage models that I thought could work, right? I then started thinking about, as you said earlier, like literally like a block diagram. I was like literally just drawing pictures of, okay, if this happens, I want this to happen or whatever. And then it took me like pretty much all afternoon on a Friday to work out here's what I want. Here's the tools that I would like to use. Okay. Here's why I would like to use those tools. Is there anything I'm missing in connecting all these tools up? Go for it. Right. And it asked me some questions about various you already have an account. Are you already signed up for this? Can you go get the API key from this service so I can connect it to this service, right? And it, like, before I even got any output, it was probably a half a day of figuring out all the various pieces, what I was going to need from various pieces, etc. And then when I got it to do the output, that part was incredibly fast, right? Like within 24 hours, and you can attest to this, you were like, what are you doing? You're like, we're going to break all this shit. I had the storage. I ended up using Cloudflare storage for a couple different reasons, but I had Cloudflare storage, and it created a multi-part chunk uploader that we could embed in our website that put stuff to the cloud storage automatically, but chunking it up and encrypting those chunks and pre-signing those chunks, just like say Frame.io does, to pop it up in the thing and spit it out at a gig a second at line speed up to that server. But in that process, you started looking at it. I started looking at it and going, well, this is stupid. We're going to have to manage users and passwords. I don't like that. I don't want to have to manage something else. Oh, maybe we could integrate it with our existing CRM system. Oh, yep, we can totally do that because there's an API available for the CRM system. Let me go get. And so like, I had this idea, initiated it. It then brought like step 2 was a huge laundry list of questions, problems, and issues that, like you said, like I couldn't roll it out in that current state. I needed to whittle those down. So I got user authentication working. I got encryption working. I got all these various things, like even to the point of like cleanup, like what happens if somebody cancels an upload? Where does that file go? I don't want to be charged for that, and so on and so forth. And so it was only through some pretty rigorous testing, which we're still in, that we even got comfortable deploying something. And just this past week, for the first time after a week of pretty much banging on straight, put it live in front of one trusted client and said, okay, try this out, see what you think.
Reduce variables.
Right. And the first thing, they uploaded a file. And you know what the first thing I noticed? Not that the file was successfully delivered. I noticed a problem. I was like, man. They uploaded 5 files and it time-stamped all of the file names. Like it changed the file names. Like that's not going to work because it changed the file names. Now the relinking in the project file and the XML they gave me is not going to work. So spent another hour or two going, you can put the file, the timestamp in a URL, but don't put it on the file. Like things like that just kept popping up. Oh, you notice one thing, it does this, it does that. And so I think that there's this little bit of misnomer in what like should be a relatively easy project, that vibe coding just means perfection out of the box. And I will tell you, it wrote a JavaScript worker for Cloudflare that was 1,800 lines long. It wrote a HTML interface or whatever UI part of this that was another 1,700 code. Like I couldn't have done that work myself at all, right? But it wasn't like the first time it did it, it was perfect right out of the box, right? It required a lot of questions, a lot of digging. In fact, I actually had to give it at one point because this was a surprise to me. I always thought that LLMs were like knowledgeable all the time, up to date to like that very moment. Right. So Cloudflare came up with an update to how their UI works, and it kept giving me instructions that were dated instructions for how Cloudflare worked. Right.
Yep.
And I eventually got sick of it, went to Cloudflare and said, oh, here's the documentation, gave that to Claude and said, please read this and give me all further instructions with this new, because its knowledge cut off at like the end of November of 2025, and here I was in the beginning of March of 2026, and it didn't know about that, right? So it's always a little bit of a give and take.
Support for this episode comes from Flanders Scientific's XMP 551 and XMP 651, the flagship QD OLED reference monitors that are reshaping modern grading rooms. Their large format and industry-leading viewing angles let clients see accurate images from anywhere in the room, and their true HDR and SDR reference performance makes single monitor room layouts possible. When everyone relies on the same display, you avoid the headache of explaining why the client and grading monitors don't match. Learn more at flandersscientific.com. You know, when we talk about garbage in, garbage out, if the data that it has available isn't current, well, it's not going to work. And that's where you need to bring real knowledge of the actual situation, kind of, you know, conditions on the ground to the project and, you know, manage it accordingly like you did. And that's, you know, that's where these tools, I know I've probably been more skeptical than most, but I also use them for writing my own tools pretty regularly. Yeah. You know what I mean?
Let's hear about, because I know one of the ones that you've done that I just think is just rad is that there's you know, you're often involved in these workflows with spot deliverables and like coming up next Thursday, next Friday, and like these cut sheets, right? Where it's just like, okay, you got one ad, but it's slightly different, 900 different ways, depending on when it's airing in the market, et cetera. And like, that's a lot of manual, like tedious work that like, God, I mean, yeah, I know you're getting paid for it, but like, why not just make, you know, work smarter, not harder kind of thing, right?
Exactly. So some of the tools that I've done, and I can't go into super details because they relate to very large media companies and their internal workflows, but right. Imagine you get a cut sheet. That cut sheet says, I have a promo I have a 30-second version and a 15-second version. And the 30-second, there's a next Thursday at 10, Thursday at 10, tonight at 10, tomorrow at 10, next, right? And they all have different tag language, and they all need, simplest thing ever, slates made, okay? Write me a script that parses through all of those data points in the cut sheet and uses, you know, ImageMagick to make a PNG slate for each one that's named accordingly. Oh, well, I also have all this information, and this company asks you to write a summary email of every spot that you shipped, including the promo ID number, the tune-in, the campaign number. Oh, well, I already had you use all that information to make all these slates. Give me the email I need to send to with that same information, right? So we're taking all the information from different places, putting it, and it's, you know, really just pointing these inputs to these outputs, but why would I manually do that? God, worst case, actually typing into the thing to make the slate? No, because that's how mistakes happen, right? But even so, copying and pasting the same thing into 3 different places. Now, of course, some of this could be mitigated by the place it's being delivered to being more efficient and having their act a little bit more together. But as post-production vendors, we know that's never going to be the case. And we know we're going to be hitting 1,000 different deliverable formats for a bunch of different companies everywhere we go. So every time we get hit with a weird challenge of, okay, now you need an Excel spreadsheet that has all the in and out time codes of these segments of this show, for example, you can literally just say, hey, whatever LLM, take this EDL I just output from DaVinci Resolve, derive these segment times based on these rules, and guess what? It'll actually work. It works really well as long as you can define the problem clearly. That's why earlier, one of the things I mentioned was, how do you actually make an EDL that works? The LLM needs to understand things like source timecode isn't optional, even if you're not using source timecode. That was one of the problems I ran into with a very specific workflow that I talked about a little bit on some of our other episodes, but basically I was given for a season of shows a massive amount of handwritten timecode notes from a producer in Word docs, right? Not an ideal way to go through your sessions and be like, oh, I gotta type in this timecode, go here, figure it out. Type in this timecode, go here, figure it out. Put it into ChatGPT. Here's all the emails from the producer with the timecodes and the episodes that we need notes for. What I really want is an EDL that has the note as the event comment, so the little starred line underneath the event, not the tape name, so that we can get the full text. And I want you to take their timecode, put it in the in and out of the record timecode with a 1-frame duration, and then copy those to the source timecode. And what this is going to do is it's going to give me a readable EDL that I can import into Resolve as markers. And it took a little bit of iteration of just explaining the output format, being able to clearly define this needs to be a compliant EDL with source timecode, with record timecode, with the character limits at the right times and the right fields and everything else, because it's more complicated than just saying, give me a tab separated list. But eventually, after about maybe 15 minutes of work, I had 8 emails of notes that were handwritten, all in my timeline in Resolve with markers at the exact right places, right?
Yep.
So that was one of those situations where me as the kind of director of all this needs to understand everything that needs to go in, everything that needs to go out from a conceptual place. And then once I can put that into a little prompt for the stupid robot goes ahead and does all my tedious work for me. That is...
I'll give you another low level example of that, because that's brilliant, and I think you hit on a couple things. That the biggest one being, like, I think not everybody, I think a lot of people tend to think about vibe coding, programming, whatever, as like, we're gonna create the next most amazing tool. Like, remember, like when the App Store from Apple and Android came out, right? Everybody's making the stupidest apps ever because they're like, there's a buck to be made. And I think that some people are treating vibe coding a little bit like that. And I think what you said, you said in a roundabout way, is that, like, it's this identification of a real world problem that doesn't necessarily have to be the biggest deal in the world. Like, you're not solving cold fusion here. You're solving a small workflow thing. And I'll give you a personal example. Recently, I've been on a string of a bunch of feature-length projects, and those projects have just a ton of deliverables, right? Like, 10 different versions of the ProRes. There's H.265, multiple DCP versions. And I found myself creating these sort of like drive inventory PDFs to, like, explain to the clients, okay, this is what's in this folder. This is the best use of this. This is what's in this folder. Here's the best. And I found myself, I had a pseudo template working, and then I would just change the client name, but it was so tedious to do. And I was like, this is a perfect job for something like an LLM to build for me. So I had it build. I said, all I want to do is I want a prompt that I point you to the output folder, right? And it's a standard, because we use a pretty standardized naming structure in our project folders. Here's the basic definition of each one of these folders. I want you to take a screenshot, like, of each one of these folders, insert it into PDF with the description with the file name, and make a PDF for me that I can put on the drive. I still look it over, but it made 45 minutes of work into 5 minutes of work, and all I have to literally do is point it to the source folder, and it makes this drive inventory with nice formatting, nice pictures, and I just hand that off to the client, and I'm done. Right.
And that's a compelling use case that we haven't had before, which is, hey, I want a computer to do something for me, but a program for it doesn't exist.
Right.
And really, it's a one-off, right?
Right.
I don't need to write a app or a website or a whatever that does. Yep. I don't need a dedicated app for this one producer's emails, right?
Yes.
But for this project, do I want to go through 1,000 of them? No. It kind of bridges the gap between fully baked, done, tested, marketable software products and base level, I need to get this task done.
So that's a workflow one, but I'll give you a creative one too, right? So one of the, as I started off this conversation by saying that people at conferences were coming up to me and saying I'm writing an app for this and that, and I think in the past decade or so, we've seen this cottage industry of DCTL plugin type folks, just pop up, right? Everybody and their mom has. It used to be LUTs, now it's DCTLs. I'm guessing at some point in the future, maybe it will be more, OFX, but that's infinitely more complicated with GPU tie-ins and stuff like that. But anyway, I got like sort of pseudo jealous for a while of like, not, I didn't say pseudo, super is the right word, super jealous of a while of all these people I knew being like, making DC. And I'm like, where did you learn that? Like, and some people were just good at learning it, right? Like, I know you picked up DCTL pretty easily because of your previous programming experience. And like, you were able to gronk real quick, like, oh, this is just the syntax. And I look at these things, I'm like, right? So perfect need of vibe coding, right? I was doing a project maybe about 2 weeks ago, 3 weeks ago, where have you ever been watching, especially like on TNT or one of those kind of networks that's always showing movies on like a Saturday afternoon, where like at the end of the movie, instead of doing the full frame credit scroll, the image kind of just like bounces up to the bottom, and there's like a big black bar at the bottom where like it just flows the credits. I needed to do that the other day, and I was like, this is manual. I had to do it like 4 times, and this is stupid. Why am I doing this? So I just wrote a DCTL, and this is the stupidest DCTL ever in history of DCTLs. It literally just put a black bar on the bottom of the screen where I now had this bounded area where I could just put the credits on the bottom, right? But it saved me like 5-6 steps in Resolve, finding that generator, putting it in, sizing it, or maybe I saved a preset or whatever. Like, I just had this area now that I could just scroll text on, and it was bound, and like, stupid, right? One off, as you said, but the ability to do those things quickly, and who cares if I never use it again?
Yeah, exactly. It can go in the trash when you're done.
I put very little thought into it, but I was able to explain it well enough for it to work, and it worked, right? And so, your level of sophistication with these things, my point is it doesn't have to be the coolest, world-changing thing ever. Think about small problems and how more efficient you could be if you solve those small problems. And I think that's where honestly, where vibe coding can step in for a lot of us is these small problems to fix, not the huge ones, the small ones and workflow things. I think it can definitely improve things.
Yeah, absolutely. It's one of those, like I kind of started with, I consider it the highest level programming language. It's an easy way to tell the computer what to do. And the real knowledge is in you being able to conceptualize what you want to do.
Yeah, and I mean, so I just want to wrap this up by saying that this is its own sort of industry now, right? As people have sort of become to see this, and as we talked about at the top, these models work depending on how well you train them, right? And so obviously some of the big players, Claude.ai, ChatGPT, those are, Gemini, those are some of the big players from the big players, right? But there's a lot of other smaller platforms. Some of the ones that come to mind are like Lovable, Vercel, Bolt. I'm trying to think of the other ones. I think it's Replit or Replit. These are different platforms that are, LLM based, but have specific levels of training for them, right? So like, if you're trying to do like a full stack kind of thing, web deployment for an app, right? Like you might go to something like Replit, right? Or if you're trying to do something like a portfolio site, you might go to another one of these platforms. The different vibe coding platforms kind of specialize in different things. So I would just say if you feel like you're not kind of getting the results that you want with one of the major platforms, check out some of these more specific things. The other thing I would put out there too is that while a lot of these platforms can do this coding stuff, there's some quality of life things that the more code specific platforms can do for you. GitHub integration, for example, dealing with different versioning of deployments, feature requests, things of that nature. Like I've gotten really frustrated very quickly by like the base level ChatGPT, Claude kind of thing, where it's like, you made me a version, I asked for a change, and then you married that back up with an old version. Like, why did you do that, right? And like, it required, like that part got frustrating real quick, and then I was like, now I'm in the process of like setting up a GitHub so I can get, better integrated with deployment and stuff like that. So there are different tools out there for different things. And I think one of the other things that you'll find in this process is that you can be really more cost efficient once you get a better handle on how these different platforms work. So in other words, you might be able to use something like Claude as your central platform, but then you're using some of these other platforms as you said earlier, Joey, like sort of module agents, right? They are really good at doing this one kind of thing. That doesn't mean that you can't combine all of them together. And it seems like you might be spending more money that way. You might not, actually. You might end up being more cost efficient in how you do this by getting things to focus on different areas too.
Yeah.
Very cool. All right. Well, that's a 90,000 foot view of vibe coding. Actually, in a couple weeks, we're going to be really excited to have on a new sponsor of ours, the guys at Conform.tools. And actually, Brandon Thomas, one of the principals there, I've had these conversations with him a bunch because he kind of caught me on to some of this vibe coding stuff. And gosh, man, when we have those guys on, I think you're going to be really impressed with the things that they've done with image detection and image manipulation and all sorts of wild things, about 10,000 steps beyond what this more complicated some of the things that we're talking about. So stay tuned for that. Just as a reminder, you can head over to the offsetpodcast.com for our full library of shows. This is our 51st show, so it'll take you a while to get through the previous 50 if you're new to the show. But wherever you find the show, please do us a favor and like and subscribe. Every like and subscribe goes a long way. And we'd love if you consider to buy us a cup of virtual coffee here at the link below on screen. Every dollar sponsor goes directly to supporting the show, helping pay our overhead costs, our editor, etc. So anything that you can do there, we greatly appreciate. And a huge thank, as always, to our sponsors, Flanders Scientific and Conform Tools. Without you guys, we couldn't do these episodes every 2 weeks, so we really appreciate that. Yeah, Joey, good stuff, man. I think that this is going to be really exciting where this goes, and I'm just along for the ride trying to figure it out as I go. But I do think for our workflows, our pipelines, some of the small pain points and things that we want to be more efficient at, vibe coding is a perfect match for it.
Yeah, absolutely.
Very cool. So for the Offset Podcast, I'm Robbie Carmen.
And I'm Joey Deanna. Thanks for listening.